Here in problem 5, what we were to do first is we were to take this linear equation in two variables and put it into slope-intercept form. This particular equation is not in slope-intercept form, it's in the standard form. And the reason I know it is because the x and the y terms are on one side of the equation and the constant is on the opposite side of the equation. This is standard form. To put it into slope-intercept form, I have to put it into the form where the y term is by itself on one side of the equation with a coefficient of positive 1, and the x term and the constant term are on the other side. So this equation is very close to that if I would simply get rid of the 3x term. And I can do that by subtracting 3x from both sides. And when I write the x term on the right-hand side, I always lead the expression with it. I have it first, so that it becomes negative 3x plus 4. Now this equation matches up to the slope-intercept form. So the m, the coefficient of x, is always my slope, so the slope of this line would be negative 3. And the b, the constant, is always my y-intercept. So the y-intercept here would be a value of 4, which is the point 0, 4. Because remember, the y-intercept is where the line crosses the y-axis. And where you cross the y-axis, the x value is always 0. So the slope here would be negative 3, the y-intercept would be 4. Let's try another one of these equations. The next one we have is 6x minus 3y equals 15. I want to take this equation and put it into slope-intercept form. That means I have to isolate the y and make sure it has a coefficient of positive 1. So I'm going to get rid of the 6x term as my first step here. Remember, when you write the x term, write it first in the right-hand expression. So it becomes negative 6x plus 15. So I'm halfway there. I now need to have a coefficient of positive 1. Well, to make my coefficient positive 1, I have to divide by the negative 3 coefficient that's there, which means I have to divide the other side of my equation by negative 3. Negative 3 divided by negative 3 gives me positive 1. 1 times y is y. That's what I need to have to be in slope-intercept form. Now I need to take each of these terms and divide them by negative 3. Negative 6 divided by negative 3 is a positive 2. And plus 15 divided by negative 3 is minus 5. Now the equation is in slope-intercept form. So the coefficient of x is the slope of the line related to this equation. So the slope of that line would be a positive 2 slope. And this line would cross the y-axis where y is negative 5. The y-intercept would be negative 5. Let's try one more. If we had the equation negative 4x plus 2y equals 8. And we wanted to write this equation in slope-intercept form. I need to isolate the y term, so I'm going to add 4x to both sides. That gives me 2y equals 4x plus 8. And now I need a coefficient of positive 1, so I'll divide both sides by 2. 2 divided by 2 gives me positive 1. 1 times y is y. That's what I need on one side of the equation is y. And now dividing both those terms by 2, 4x divided by 2 gives me 2x, plus 8 divided by 2 gives me plus 4. The equation is now in slope-intercept form. And the slope of the line would be the coefficient of the x term. So the slope of the line related to this equation would be a positive 2 slope. And the y-intercept is the constant. So the y-intercept here would be positive 4. So when you have an equation in standard form, you can rewrite it into slope-intercept form using an approach such as this, and then you can immediately identify the slope and the y-intercept of the line related to that equation.